Hello, I'm Mr. McChesney, and today we're talking about heat and heat transfer. So we have a problem here that says, suppose that you are camping in the mountains. You need to melt 1.5 kilograms of snow at 0.0 degrees Celsius and then heat it to 70.0 degrees Celsius to make some hot cocoa. How much heat will be needed? So one of the things we want to do here is, when you're doing these problems, sketch a little diagram. It doesn't have to be as nice as this, but just something showing you had some ice and then you're going to have some water later on. And you can include things like your initial temperature, your final temperature, how much was the mass of the stuff you started with, the fact that you're putting heat in, then there's heat of fusion, which means melting the ice, changing it into water. And so when you do that, you always, after making your diagram, then want to start with, what do you have? So again, even though I wrote it on my diagram, I want to write out my known values and then what I'm looking for. So my mass of my water, or my ice, is 1.5 kilograms. My initial temperature is going to be the temperature of ice, which would be 0.0 degrees Celsius. I've got a final temperature that is 70.0 degrees Celsius. And then I've got some other things I know. I know from looking back in the chapter earlier that my specific heat of water is 4,180 joules divided by kilograms times degrees Celsius. And then I've got a heat of fusion that is equal to 3.34 times 10 to the 5th joules per kilogram. So what don't I know right now? Well, I don't know how much heat it's going to require to melt the ice. So that's one of my unknowns. I don't know how much heat it's going to require to get it into the liquid phase and get it up to temperature. And then finally, I don't know what the total or the number is for everything added together. So this is really a two-step problem where you have to add the final two answers together. So let's start with the first thing, melting the ice. So I'm going to call that QMI for melt ice. And if you look back, we see that to melt ice, you take your mass of what you've got times your heat of fusion. So that is 1.50 kilograms times my heat of fusion, 3.34 times 10 to the 5th power, and that's joules per kilogram. So if I'm looking at this, I see that I'm looking for how much heat's required to melt this, which is a unit of energy. And I'm taking a kilograms times a joule per kilogram, which means my kilograms cancel out. And I'm going to get my answer of 5.01 times 10 to the 5th joule. Now if we're looking at that answer, that's a kind of a large answer, and sometimes using the metric system we can convert that answer into something a little more manageable. So I'm going to do that. I want to convert it into something that has a little better units. So I want to get it out of joules, and I think if we use kilojoules, that would work out pretty well. So I got 5.01 times 10 to the 5th joules, there are 1,000 joules, or 10 to the third, in 1 kilojoule. So if we do that, when I take and multiply an exponent times 1, nothing happens, but when I divide it by 10 to the third, I'm going to take 5 minus 3, so my answer should be the same number, 5.01, but with a new smaller exponent, times 10 to the second kilojoules. So that's my first answer. Now we can move on to the second thing we need to find. And let me just label one thing here since I left it off. My Q is my melt the ice. Now we can do the heat required to heat the liquid up to its final temperature. So if you look back, when you're heating something in the liquid state, you take its mass times its specific heat times its change in temperature. So that's going to be equal to, again, my 1.50 kilograms. And then I multiply it by the specific heat. If you look up, we see my specific heat was 4,180 joules divided by a kilogram times a degree Celsius, and then I'm going to multiply that times my change in temperature, which is my final temperature, 70.0 degrees Celsius, minus my starting temperature. Once the ice melts, it's still going to be 0 degrees Celsius. So my heat required is going to be 4.39 times 10 to the fifth. It's a unit of energy, heat is. And if we look, we've got kilograms divided by kilograms. We got, when we do the subtraction here, 70 minus 0, we'll get 70 degrees Celsius. So my Celsius on the bottom of the fraction will cancel out the Celsius that'd be on the top of the fraction. So the only thing I'd have left is joules. And again, that's a rather large number, so let's convert it. 10 to the third joules, 1 kilojoule. Cancel out my joules, and you'll get an answer that's 4.39 times 10. Subtract your exponents. 5 minus 3 gives me 2 kilojoules. So now I have my second answer I need. And the last thing to do is just add those numbers together. So I'm going to get my total heat required to do this. My Q total. So again, that's going to be the heat to melt the ice plus the heat required to get the liquid up to temperature. So we're going to take our numbers we had before, the number we have in the green box, 5.01 times 10 to the second kilojoules plus the number in the blue box, 4.39 times 10 to the second power also kilojoules. So as the final answer for my total heat required, since my exponents are the same, you can just add these numbers together and you get 9.40. You can just add the simple parts, the front number, together, and you keep the same exponent times 10 to the second, and you have the same unit, kilojoules. So that's your final answer.